Okay, hey y'all, this is video number 2 of this nomenclature series. Previously we went over binary molecular compounds, and now we are going to go over our ionic compounds. So there are a couple different types for this, right? So our first type is going to be our monatomic ionic compounds, awesome. And then the second one is going to be the just ionic compounds. But these are going to be, some are going to be polyatomic, right? So they're going to have more than one element within them. So for the first ones, monoatomic, that's what we're going to be going over first. These are going to be singular ions, right? So we have specific rules for those. So monatomic down here, these ions are either going to be cations, which are positive, or anions, which are negative, right? So we have some different rules of naming these depending on what group everything is, and I would say that learning oxidation state is going to be key for knowing how to name some of your ions, especially your transition metal ions, right? So I'm going to draw a quick periodic table here. I'm sorry if this is not up to standards, but whatever, quick drawing. Skip 1, 2, 3, awesome. So we are going to learn about oxidation state because that's going to be important in picking out your charges. So everything in this group, right, groups go down. So we start at the top and we go down. Everything in this group is going to have a +1 oxidation state. So this is the column starting with hydrogen. Next that'll be +2. We skip all the transition metals, so T metals, we're going to skip those, and we're going to go to +3, and then we skip, and then -3, -2, -1. So that is how we count oxidation numbers. And those will come in handy, especially in the polyatomic ionic compounds part when you do have to balance, especially with your transition metals. So that being said, getting to the rules. So for cations, if you are going from group 1 to 3A, and so that would be these two groups over here, and then this is group 3A, right? So if you're going from one of those, and then if it is nickel, argon, or zinc, how you name this is just going to be the name of the element, plus the word ion, right? Pretty awesome, right? So if we tried to name nickel, if we were just given like, oh, I have a nickel ion, awesome. Well, I just said it. But how you would name this, you would just go, oh, that's nickel. It's on my nice little list, so nickel ion. Easy enough, right? So the next would be the transition metals. I'm abbreviating that as T metals, or your group 4A elements. These are a little different because we don't know the charges. So we don't know charges. They can change. There are many different isotopes. We do our best to name them. So here, with any of these, we will start with the name of the element, per usual. Then we're going to add the charge in Roman numerals in parentheses. So charge in Roman numerals. Awesome. And then we just add the word ion, right? So kind of the same, but this time we are adding the charges. So if I can think briefly, iron 2+. The charge on here is 2+, and since it's positive, it means it's a cation, so I'm going to follow these rules. So I'm going to have the name of the element, iron, and then the charge in Roman numerals in parentheses, so 2. And then I add the word ion. So iron 2 ion is how you would name that monatomic cation. Okay, so that was cations, and now I will do our anions. So the rules for this are, you're most likely going to have a nonmetal, right? And it's going to be the root name of the element plus "-ide", plus the word ion. So it's kind of similar to what we did in the binary molecular compound parts, where the second part of the words of the compound are going to have a suffix on them. So let me think of a lovely non-metal here. Let's do oxygen 2-. So I know it has a 2- charge, so it's an anion, so I will have to follow these rules up here. And I also know that I'm going to take the root word out of this, so oxygen. I'm going to take ox, and then I'm going to end it with ide, right? So oxide, ion. Oxide, ion. Fantastic, right? So let's do a couple example problems. Let's do F- carbon ion, and then okay, so looking at all of these, starting with the first one, I'm going to recognize what element that is. F is going to be fluorine, right? So I have fluorine. Sorry if I didn't spell it right. I'm bad at spelling. And I'm going to look, is it a cation or an anion? Negative means anion. So I'm going to follow the anion rules. I have to pull out the root from this word. So I'm going to pull out the fluor part of it. And then I have to add ide. So I'm going to go fluoride. And then I'm just going to add the word ion. So this is a fluoride ion. Fantastic. All right. On to the next one. Carbon ion. What does that tell me, right? Well, I can see that for sure it's going to have a charge on it. Awesome. And it does not have a suffix. There's no suffix. So it's probably going to be positive, right? So how I would write this is I would get the element symbol for carbon, which would be C, and then I would figure out what its charge is on the periodic table, and I believe it is in group 2A, so it would have a 2+ or +2 charge, so it would be C, 2+, carbon ion, right? We can apply the same level of thinking to the next one, magnesium, right? So I know that this is magnesium, and I also see that it has a positive charge. This is a cation, which means it does not need its suffix changed. So I'm just going to have my root word, magnesium, and I'm going to add ion. Simple as that, right? Pretty cool. So moving on, this was all of our monatomic. So now I'm going to go over some of our polyatomic ionic compounds, how we name them, how they're different, and whatnot. So looking at this word, these were all monatomic. And if we remember, our prefix is mon means one, right? These are poly. So this would be greater than or equal to 2 or more elements within each compound. Very cool, right? So there's a couple different ways that we can tell if it's, an ionic compound with 2 or more elements. You're going to see in this case, it could be a metal or a nonmetal together, right? It could be a metal or one of our polyatomic ions that you should all be studying up on. It could be a nonmetal and a polyatomic ion. I'm going to abbreviate that. Or it could be 2 polyatomic ions. Poly plus poly, right? So we have 4 options of what these could look like, right? So the way to name these actually is going to play off of our monatomic ions, and it's just going to be the first word, right, is the name of your cation. So whatever your positively charged ion is, just name it. Awesome. And then your second word is going to be the name of the anion. So if you can name your ions, your monatomic ions especially, and your polyatomic ones, and figure out which one's positive, which one's negative, you just take those words and put them together. The general trend is we're dropping ion. So name your ion, drop the word ion, and that's what you need to name it. So if we're going to do some examples, let's start out with Ooh, this might be a little difficult. Got that one. NH4NO3. How about NaCl? All right, calcium carbonate. And, oops, 4. We'll do sodium sulfate. So these are all really good examples of polyatomic ions. So let's start at the top. NH4NO3, right? If you had been studying your polyatomic ions, you would know that both of these are polyatomic ions, right? So I'm going to break it up. I have NH4 and I have NO3, right? NH4, I know what this is. I know it has a +1 charge, and it is an ammonium ion. Awesome. NO3, I know this has a -1 charge, and if I was studying my polyatomics, I would also know this is a nitrate. This is a nitrate ion, right? So how we would name this is just get rid of the word ion and put these together. So this compound is called ammonium nitrate. Cool, right? Easy enough. So next one, this one should be pretty common. This is table salt, NaCl. I'm going to break this up into my cation and my anion, and just a little hint, usually our cations always come first and our anions always come second. So that'll help you out. But I'm going to break this down. So I have sodium. I know that is a +1 charge, and it's a cation, so I'm going to name it sodium ion. I also have chlorine, and I know by my oxidation state that that is a -1 charge. And so to name this, I would take the root word of chlorine, chlor, add my suffix "ide," and then put an ion on the end. So chloride ion. If I want to name it, I get rid of ion, add them together, and NaCl is called sodium chloride. Cool. All right, next one. Opposite. Calcium carbonate. Calcium is going to be the name of our cation, so I need to know what that looks like, and carbonate is going to be the name of our anion. So just looking at calcium here, calcium ion. I'm going to need to know where that is on the periodic table and what its oxidation state is. I know by looking that it has a +1 oxidation state, +3 oxidation state. So this is what the calcium ion looks like. Calcium ion, awesome. Next, I'm going to move on to carbonate. Carbonate, interesting. Because it has this lovely 8 here, I'm going to assume that it's a polyatomic ion because most of our polyatomics have a suffix like ate or ite, right? So now I have to think of what polyatomic has carbon as the main element. I'm going to say it's something like CO3. CO3 minus, right? Oh my goodness, I'm so sorry. Calcium does have a +1 charge. I'm going nuts today. Okay, so CO3 minus. Awesome. And this is a carbonate ion. Carbonate ion. So now you just have to balance them out. And if we add them together, we see that their charges are already balanced. So it'll be CaCO3. And we do not need to include any charges in the final answer when we write that. Okay, last one. Sodium sulfate. Break it down, right? We did sodium up there. So if we come up again to number 2, we see that Na is sodium. And that's something you should remember. Pretty important. So I know I have Na+. And then I have sulfate, again with the 8. Probably a polyatomic ion. And then I have sulf, most likely sulfur. So I have to think what polyatomic ion ends in 8 and has sulfur as one of the main compounds. Sulfate, and I'm going to say that that looks like SO4 2-, right? So if I put these together and I balance them out, I will need 2 of my sodiums per 1 of my sulfates. So then I can just write it Na2SO4, sodium sulfate. All right, and that is the end of our ionic compound lecture.